be less or equal to 1 plus 1 over 2 plus just change it to 1 over 4 plus 1 over 8 plus 1 over 8 plus 1 over 16 plus 1 over 16. You can see that this one is 1 over 2, this one is 1 over 2, this one is 1 over 2. So it diverges. Okay. Any question before I start? I cannot hear you.
Sorry, I got 4 over 1.
4 over 1. 1 over 4.
More than 3 over 1. Actually, last time.
Sorry,
It's square root.
Yeah, it's square root. And this one diverges and this one diverges. It's like comparison test. So as you can see, like every test is a comparison test. The ratio test is a comparison test. Root test is a comparison test. You're compare with different series. Like any questions about the test? I mean, different convergence test. Do I need to go through like any proof of it? If not, I would rather write it down because I think it's quite repetitive. Do you think like what test is rather hard and we need to go through it? Test, ratio test, comparison test. No M test, right? I don't think so. What do you like? We have kind reminder first. The due for you to drop this course is, I think it's this Friday. Yeah. And I think the letter grade will be similar to what we have announced in the very beginning of this course. So we have a mock letter grade after maybe like the first quiz or second quiz. I cannot remember. And the cutoff for the final letter grade will be similar to that one. So you find out it, okay, you will not make you cannot make it. It is the right time for you to consider if you need to drop this course. Or come to office hour like more often. No. Okay, no question on test, so I just like list them out.
Can you give a letter grade, a mark letter grade again based on positive or negative?
Of course. I can do that. Maybe Wednesday. one, the comparison test. That larger an larger than an larger equal to bn larger equal to 0. And if an converges, then en converges. So the second one is just the reverse version of the first argument. It will be equivalent. That is, if en diverges, then an converges. That's a comparison test. And I think it's intuitive if something like grows slower than another one. If the one is close to its down, then it should be like converges. And ratio test. Root test first. Root test. Yep. Yes. An larger or equal to 0. If limit soup an over n is less than 1, then n converges. And the second, if it larger than 1, then diverges. So how do you see this one? Just compare it. Just if limit of an to the 1 over n is less than 1, which means that this number is less than 1, or less than something less than 1. So okay, I'll read proof it. Proof. One or brief proof. So if limit soup over less than 1, then there exists a large enough n such that an is there exists the beta less than 1 such that beta. And why is this? It's because you can just take beta to be the, just like think about, take beta equals to 2 over maybe soup plus 1. So you can find this beta, and we can find out like for large enough n, you have this inequality. And just do comparison tests. With beta to the n. So this one directly shows that this one. Right? And you know that this one converges. So for large enough n, this one dominates this one, and this one converges, so this one converges. This is a comparison test. So actually, you don't need this to be like for every term. You just need that to be for large enough. And the second one is trivial because if this one is larger than 1, which means that an larger than 1 for some very large m. You understand this term? So like, because this limit soup is larger than 1, which means that for you can find a very large, so which means that no matter, I'll write it for me. I'll write this one formally. It means that for all n there exists n such that this one I mean, and it's just directly from limit soup larger than 1. We can get this one. So that n does not converge to 0, and so the series cannot converge. Right. Ratio tests. Ratio.
Wait.
Hey.
Wait, hold on.
Hey.
So, I see, so you take this, the root, the nth root,
Yep.
but that's not in the statement of root test, right?
That's the statement of root test.
That's not in the statement of root test.
What is not? You mean this one? This one is
No, I mean, in part 1.
in part 1? This one?
Yeah, so
This one?
you're only taking the square root in your statement, but there you're using the nth root.
No, it's the answer.
Yeah, that's what I meant.
Oh, I see.
Yeah,
It's
it's
like,
nth root, it should be nth root.
okay. Okay, the ratio test, let's see. That's an larger than 0. May not need, but okay, we don't need that's and to be a series. And we need what? We need an doesn't equal to 0 for large enough n. So if limit soup an plus 1, an is larger than 1, sorry, is smaller than 1, then this one converges. So again, this one is comparison test, right? Because you can see this one is smaller than 1, so you must find a beta here between them and controls it. So after some term, it will decay faster than a geometric series. So same argument there, right? increases, at some point, began to increase at some point, it cannot be, the series cannot converge. It's like, the term does not converge to zero, so the series cannot converge. Something like that. Okay, cool. Okay, I think we have gone through every test. And I think this one is the hard one. The root test is the hard one. So yep. Okay, so like if you find out maybe you do not know how to calculate some limit in the test, maybe you can try to first prove that the test the series converges. You'll get multiple points. Yeah, maybe with some of these tests, you can see some convergence. Okay, Abel theorem. I'll just write down a statement, proof. Do we have time? Yes. Maybe not. So, an equals to ai from 0 to n. Found it. And bn goes to 0. And sum over an bn converges. So how is this useful? Maybe one can think about you're trying to solve something like do you have one? Let me think about it. Do you have yeah, maybe you have that one. So if you want to solve something like example sum over n over 1 sine n over pi. Is it does it converge? Does it converge? So you can think about, you see this one converges to 0. So maybe you can think about that that ai equals to an equals to sine and bn equals to 1 over n. This one that converges to 0. Alright, this one is simple. How about this one? Does this one bound it? Sorry, maybe it's my fault. 3. Let me check. I would like to write down something like this. That's my fault. What I'm trying to write down is yep. Yep, this one. This one bounded. So maybe try to draw something like 4 over n pi. So you're trying to say that you're adding up the values of sine like circulately. So A0 will be 0, and A1 will be A1 equals to 2 over square root 2. A2 will be 1. A3 will be this 1. And A4 will be 0. A0 will be 0. Something like this. Yep. So if you adding up like 8 terms, it will turn back to 0 and it circulates. It's a circulating series, circulating, what is that called? Circulating sequence, yeah, sequence for AN. So it must be bounded. Right, so this one's bounded, this one converges 0, so this one converges. The proof is like this. Okay.
Hey, why your Bn is not monotonely decreasing?
Why my Bn is not monotonic? Oh, sorry, yes, you're right. Monotonic decreasing.
Maybe they have three conditions.
Think about it. Do I need a monotonic decrease? If I want to change it into that one. Yeah, maybe we need to yeah, we need monotonic decrease. That's really right. Monotonely decreasing. Yes, you're right.
And also limit 0.
Ah, sorry. Yes, 3 conditions. This part is mainly about like technical stuff. So we're thinking about like when is a series converge, when it's not. So you just put a lot of tests on a series to see if that converges or not. And I think the main idea of that is just keep trying to find a series. Let's try to find a comparison test behind what you want to test. I mean, like if you want to do ratio test, you want to, actually this one is alternative version of comparison test and also the root test. So you're seeing that we're doing comparison tests here. We're doing comparison tests somewhere here. So if you cannot like solve your problem with these tests, just try to think about if there is a sequence that you can control and do comparison tests, because like the spirit of these tests are comparison tests. Just like fancy version of comparison tests, but in like truly hard, they're just comparison tests. Add this loop to the convergence. Yep. Just like try to observe a series that is like 1 plus 1 over 2 and minus 1 over 2 plus 1 over 3 plus 1 over 3 plus 1 over 3 minus 1 over 3, sorry, plus 1 over 3 minus 1 over 3 plus 1 over 3 minus 1 over 1 plus 1 over 2 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 3. So, okay, observe this series. So we just repeat it, plus 1 over n minus 1 over n for n times. Does this series converge or not? This one converges, right? So the value would be 1, sorry, minus 1. 1 minus 1. So it means 1, 0, 1 over 2, 0, 1 over 2, 0, 1 over 3, 0, 1 over 3, 0, 1 over 3, 0, 1 over 4, 0, blah, 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 blah. So this one converges to 0. Yep. But if we just like do some rearrangement, like 1 minus 1 plus 1 over 2 plus 1 over 2 minus 1 over 2 minus 1 over 2 plus 1 over 3 plus 1 over 3 plus 1 over 3 minus 1 over 3 plus 1 over 3. If we do something like this, does this one converges? It'll be 1, 0, 1 over 2, 1. And 1 over 2, 0. So it'll be 1, 0, and 1, and 0, and 1, and 0, and maybe 1. Right? It's 1, 0, 1, 0, 1, 0. So this series does not converge. Does not converge. But I just rearrange the terms here. Just can you see? I just rearrange this one to this one, arrange this one to this one, and so on. I just rearrange the terms. And by rearrange these terms, I can make a series from convergence to divergence. Oh, I think she heard series and something like that. Okay. So that is to a like natural question that which series still converges after the rearrangement. Alright, and that brings to the definition here. That AN will be a converged series if the absolute value of AN converges, then we say this one is absolutely converge or converge absolutely. And if not, we call it conditionally. If not, so like in Chinese, maybe 绝对收敛 and 条件收敛. Okay. Arrangement. So if this one is absolutely converged, then any rearrangement will be fine.
So where's the one? It still seems to be 1 minus 1.
Where? You mean this one?
No, this one, the second one.
Yeah, this 1, 0.
Where's the 0?
1 minus 1. So the value is 1 minus 1 is 0. And the value will be 1 over half, 1 half, 1, 1 half, 0, So, we have time. I don't think so. So, the main argument is, so I cannot remember. Did they prove this? No? If we don't prove this, we don't prove this. So, I'll tell you about like how it works. If this one converges, then I'll say that maybe A, this one is original series, and AI prime is the new series. Right? And we want to say that this one converges, we need to control. So if to prove, so what we want to show is to say that J from N to N, A J prime, this one, sorry, this one. That's the absolute. For some, for and large enough. Right? And you can see that this one is larger or equal to J to the M AJ prime. Yes. And you know that this one is larger, sorry, smaller or equal to J to the N to infinity AJ prime. So by this kind of rearrangement, if N is big enough so that this, so you know that there exists some N such that this one is less than absolute. And you make this N large enough so that the terms before this AN are not included in this one. The proof is none. So that this one is controllable. We don't have time, so I just brief the proof. Any problem? Do I need to repeat it, or you can understand what I'm talking about? Okay.我讲得完吗？等一下，we still got a chapter, right? Let me think about it. Do I need to like change my problem? Yeah. Sure. Sure. 我们把第三题改成原本那一条好不好？还是？
我不知道有个问题是什么
那个
什么 log 的什么的吧？
哦，反正就是一个 test 的题目。
我听起来不太对。
不然送分吧，送分。
不要了。不是，可这个也可以。
你没有复习完。
可这也不用讲。我等下换题目。我 test on this on exam, but maybe not.
不要换。
不要换。
不是说影片要讲。
OK。
真讲。
OK。
什么军品？军品卡，让我们看一下，会不会？
So, I'll tell you what is the problem, and you can like maybe solve it in these in 20 minutes. what I'm testing is if an, en converges absolutely, and cn equals to I over I equals to 0 over n a I bn minus I. Then sum over cn converges.
The proof. Or what?
Yeah, you need to prove this. So I'll give you the hints. I'll give you the hints. The proof is like this, and you need to like write it down formally when maybe the next period. So you're thinking about this one is A1, B1, A1, A2, B1, B2. So for C1, you do this. For C2, you do this. For C3, you do this. Right? So what you have remained is, so for, you're trying to say that you want to show Ci, I from n to n. This one, that's absolute. Right? And so you're trying to say that this one is lower than Ci, something like this. And you find out that, okay, so what is this from this one? It will be to m to the m, n to the m, something like this. Right? This one is this. The strip here. And this strip can be controlled by two things. That is, you can find the midpoint. Find the midpoint. This is important. Midpoint, right? Midpoint, and you do this, and this. So this one can be controlled. This one can be controlled, and you know this strip lies in this one plus this one, and so this one can be controlled. Okay?
Magic. I think proving the absolutely convergence of Cn is easier.
I think they'll be the same. They're just to control it.
This is not in the video.
It's not in the video, but I just give you a hint.
There's an easy way to do it, trust me.
You can give another hint to them. That's how I think this problem is.
You can prove Cn absolutely converges or Cn converges.
But if you prove Cn absolute convergence, you're dealing with this product, and so
Yes, you're dealing with the term with the absolute value.
yes, that's what I'm doing.
That's to 抽象.
Abstract.
Yeah, abstract. Yes.
Is this what abstract?
I said it's magic.
Oh, you.
I think
It's magic.
also.
It's magical.
Also,
Yes.
you will become like you can prove this converges. So what you need to do is add a absolute value here, and this will equal to something like this.
Yes, and that's what I'm saying. You're just controlling. Yeah, of course.
Okay, so then you can break these two if you sum it up from maybe 0 to n. Then you can split this one to sum and use the absolute conversion.
That's what I'm saying. You are split it into this one and this one. Okay, fine. I know, but
So that was dark magic.
Right. Okay. So,
Well, if something's absolutely convergent, then it's convergent.
So proving that is absolutely converges, right?
In this case, yes.
so maybe we'll give the maybe again we'll let you to have maybe half of the points for free. Maybe it just like depends on how I answer this question. If like everyone can get this right, it's no point.
Depends on.
Okay, so the limits of function. I'm running out of time. Limit of function. So the point here is, first one is as a definition. As a definition. How much time do I have? I have like negative 11 minutes. So I'll just tell you like what is important, and maybe you can wrap it up by yourself. The first one is definition, and the second one is you're doing this, the limit of sequence in the limit of function. So formally it would be if limit x to the p f of x equals to L. That means that for xn to p f xn to L. That's the proposition. Right. Important proposition. Very important proposition. Maybe like worth 25 points. Okay. I think there's like another one that is. So what we mean by limits? What we mean by continuous? We actually mean by f of limit equals to limit x n to p x n to infinity xn equals to limit so when f is continuous, then we have the limit, the function of limit equals to limit of function. Yeah, so this one brings some corollary that f plus g is continuous. So if f, g are conti, then f plus g is conti, and fg is conti. F over g is conti if g does not equal to 0 at all x. This one, you can use this one. Alright, you can use this one. Okay. We'll start the test at 30. Is that enough for you? Or 35? Sure. Okay, 35. This one is important, and this one is important, and this one is important.